in 2.1 number 24, there's speculation of parts. Speculation about parts.
At the very end.
At the very end.
Yeah.
Okay, cool. So first, what kind of beast is this?
First order ordinary.
Okay.
It works.
It's a differential equation.
First order. It's an ordinary differential equation. Yes. Good.
Homogeneous.
Linear, yeah.
I've always wanted to do
It's linear, yeah.
Non-hom.
And then it's non-homogeneous. Okay, so how do you solve this?
Make it homogeneous.
You assume the homogeneous case.
You just
Good.
call it what you want it to
So first, multiply through by 1 over x squared.
Yeah, that works.
So you get y prime plus 3 over xy is e to the x over x squared.
Yeah.
You did it this way.
Oh, can't you just take out the e to
That
the
works
x
the
and then use that as your homogeneous equation?
Sure.
I did it the other way.
Okay.
So in either case, right, whether you divide first or not, the first thing you should try to do is solve the homogeneous version, right? So in my case, the homogeneous version looks like yh prime plus 3 over x yh is 0. And then I'm going to say, okay, so I know the form of the homogeneous solution. It should be e to the minus integral of 3 over x dx. And if you didn't do this, you would have an x squared here, sorry, here, and a 3x here, and you would say to yourself, I should divide by x squared, and you'll get to the same spot.
Yeah.
Okay, so I got here, let's see, integral of 3 over x
A
is,
over cube, x cube.
so you got yh is e to the minus 3 log absolute value of x plus constant.
It's just absolute value of n by absolute value of
Which
x.
is A
It's
over
like
x cubed.
Okay, and then you get, so y homogeneous is a over x cubed. Cool.
and then you do things and stuff.
And where did the absolute value go?
Into the AA.
In
Plus or minus e to the z.
cool. Alright, so then what? This?
You take a big old guess. This
Add.
is u.
Guess that a is a function of x instead of a constant.
Yeah, so you say, alright, so we are now going to guess y is some function u of x times this thing. Do I need the a?
No, that's not you.
So you make your life a little easier and forget the constant, right?
And you integrate.
Differentiate.
Close enough.
The opposite of that. So differentiate, so you get
Close to that.
u prime of x times 1 over x cubed plus u of x times
That one thing, so negative 3
over
over
x
x.
to the fourth.
negative 3, 1 over x to the fourth. And then what do you do with this?
Plug it back into the first thing.
Good. Take your guess, shove it into your...
No, why can't you throw it in the next thing?
Oh, totally. Yeah, you can put it in either here or here, doesn't matter.
They tend to cancel out not canceling
It should cancel both places.
Yeah.
I'm going to put it into here just to spite you, Chris.
Yeah.
Ha! Take that.
There.
Well, you should.
But again, it doesn't matter at all. So you got y prime is this crap. So you got u prime times 1 over x cubed plus minus 3u over x to the fourth plus 3 over x times u times 1 over x cubed is e to the x over x squared. And then this is where the magic happens.
Things cancel because they do.
Things cancel because they always do. This thing and that thing cancel.
And then truth is revealed. You find you, and then you like
U prime
Do your
equals x
thing.
e to the x.
Okay, so you got u prime is, so now we need to multiply both sides by x cubed. So you get u prime is x e to the x, and then you're like, whoa,
Integrate everything.
I want u, so u is going to be the antiderivative of x e log, sorry, x e to the x
This
dx.
is where you leave the problem, right?
No.
You just save the
Yeah.
So
this
that's like
thing.
x e to the x minus
Yeah, so then you just need to remember how parts works. So
voodoo.
E to the x.
Ultraviolet voodoo.
So you need uv minus the integral of v to u, right? So you need to, and that's the integral of u dv, right? Is that
Yeah.
correct? So you need a u and a dv. And the thing you want to differentiate here is
E to the x.
x, because it'll go away.
Aw.
So your du is 1
I
dx,
did partially corrected the first.
and your dv is
Yeah.
e to the x,
Yeah. And b.
and then v is e to the x, sorry, dv is e to the x dx, and v is e to the x. And then plug all that in, you get u is, oh, u is a Chromie variable choice.
You have. You could always just do stories thing.
That's why I always do u of x.
Yeah, I was thinking like story would have blasted in this class, just any symbol.
Whatever, yeah, so you got uv is x e to the x minus the integral of v to u is e to the x dx. So you get u is x e to the x minus e to the x
Plus e.
plus and minus.
Then plug into guess.
Good. Then take this, trot it back up to your guess. So you figure out that y is 1 over x cubed times all of this junk. X e to the x minus e to the x plus a constant. Oh, done. Cool.
So we have initial conditions.
Are there initial conditions?
I don't think so.
Thank
No.
goodness.
If there were initial conditions, what would I be solving for here?
C.
Good.
And that's another 2 whiteboards later.
It's like
Like 2 steps.
not really.
Yeah, my hope would be not really. My hope would also be that you would notice that there's a problem if they ask for u at or y at 0.
Yeah, because
It's probably fine.
It's not.
You have to take the limit. Take the limit.
Yeah, this is actually an interesting question, right? If, like, for instance, we're asking about x is 0, this is kind of a funny equation if x is 0. Right?
yeah,
0 equals 1.
Yeah, so
probably
that's
fine.
probably not going to work. That's one of those kind of interval of validity things, right? Like, no matter what you pick, it ain't going to work past 0.
Would you like do a limit thing and see what it does?
God,
If it does anything?
no.
No.
Because it's like a 2D, 3D limit. Because it's
You're asking for problems there. Yeah, well, some of these limits you can approach and get reasonable things. We'll talk about some problems in the tank area where the limits make sense, but you're